Okay, seventh problem, again, it's not easy. And kind of looking at it, I guess I could square both sides, right? And that looks pretty easy to do it, actually. And what do you get? X minus a root of bx plus a4 equals a squared. All right. So I'm going to kind of isolate the radical. So it's going to be x minus a squared would be equal to that radical bx plus a4. I'm going to square both sides again. And what do you get? You would get x squared minus, let's be careful, that's going to be 2a squared x plus a4. And if I square the other side, you get bx plus a4. And again, I'm not worried about, when I square both sides, I can introduce a wrong solution to the problem, extraneous solution. I'm not too worried about that. But I'm going to subtract a4 from both sides, and I'm going to subtract bx from both sides. And what do you get? X squared minus 2a squared x minus bx equals 0. And someone says, why would you do that? I see it as being factorable. And I'm going to use what's called the zero product rule. X comes out, and you're left off with x minus 2a squared, let's see, minus b equals 0. So x could be 0. That's the first factor, could be 0. And for the second factor to be 0, the x would have to be equal to 2a squared plus b. All right? Now, granted, if you get there, congratulate yourself. But you know what? I'm not going to rest on that. I want to see if it's true. So I want to check the easy one first. I want to check this. And if you check the 0, and again, I want to emphasize you're checking the original problem. What would you get? You'd get the root. Whoops, I didn't mean to do that. You would get the root. I'm going to plug in 0, by the way. And this is equal to a. If you plug in 0, what would you get? You would get the opposite of the square root of a4. Well, this would be the opposite of the square root of a squared. There's trouble over here. And the trouble is this is a non-real solution to the problem. So I'm going to say this is not a good answer. It's extraneous. The question is the other one a good answer? Now, by the way, the fact that one doesn't work doesn't mean the other one's not going to work. You got to plug it in. And part of plugging it in is just plugging it in. And let me write this down for you. So it's work, though. I know it's work, and I'm going to plug it in. And what would you get? You'd get 2a squared plus b minus a root. And that root's going to be what? It's b times that x value. So it's going to be 2a squared b plus b squared plus a4. Okay, I got to keep going. And someone says, why do you keep going? I don't know if that's true. You know what? I realize I can't fit it in there. Let me put it down over here. So what do you get? I'll write this down for you. You get 2a squared plus b minus, and they said it's equal to a, right? Well, I'll be honest with you. What I noticed about this guy over here, it's actually a perfect square. Let me write that down for you. And it's going to be a squared plus, let's see, I got to make sure, 2, a squared plus b quantity squared. Let me just make sure that's true. You get a4, you would get b squared, and then you get 2a squared b. Yeah, it worked out beautifully. So what do I now know? I know this. I'll put this down. 2a squared plus b minus the square root of that, which is going to be a squared plus b. By the way, there's conditions under which that could be a problem, but we're not worried about the parameter problems in the problem. And what does this give you? Well, 2a squared minus a squared is just a squared. And, b minus b is just 0. And again, there's conditions under which this would not be true, but this is equal to a, provided a is a positive number. all right? But they're not asking restrictions on this, all right? But there are restrictions, all right? So we got our answer. I want to point out, if you look at this over here, using the zero product rule, which we did, we got two solutions, checking your equation, this is the only answer over here. And again, it's important, you know we only found one solution to the problem, and we're in agreement, all right? Thank you.